That was a very sexist joke. Alright, so there's your homework just in case, but we're on here. So, Anessa has this parabola that she's going to try to sketch. No, Anessa. Alright. Now the equation of that parabola is what? Now, based off what we were talking about yesterday and what we figured out, or based off what you graph in your calculator, you have a toothache. That's what they used to do when you had a toothache. They'd pack ice or something. Just checking. Are you okay? Yeah. I know if you had a headache or something. I've seen people do that for all kinds of reasons. Like your ear got chopped off and you're trying to keep pressure on it. Or...
We're not talking about bread.
No, because he just has this stupid racket. I don't think he's trying to do anything. At least I'm assuming positive intent, that you're just being a goofy 8th grader and you're not trying to be offensive. Right? Try to assume positive. So, what does the parabola look like? And if I ask us a checklist of things we're looking for, would this one be flipped? No. Would this one have the intensity change? No. And as we go through today, and you're complaining about graphing the parabolas, if we remember back to the parent function, which actually I'm going to change colors for this guy. Well, purple's kind of dark. I was going to go a bit lighter. To the y equals x squared. I have the points 1, 1. Then when I go to 2, I'd be at 4. 3, I'd be at 9. So 5, 6, 7, 8, not way up there. Get comfortable with what that kind of looks like. You don't have to be perfect, right? I'm not looking for amazing.
That's the point.
Yeah, that's the point. It's a sketch. But the sketch needs to show 3 things. What direction it's pointing, which it should be really obvious, where your vertex is, and if the intensity of it has changed. So we normally need to do how many points?
3.
Nope.
6.
Okay, 5, really. 3 will do it, kind of, but 5 to be safe.
I guess 6.
Hey, peeps. We're still really loud. I'm trying to teach
Jenny,
March.
I tried to FaceTime you like twice during the orientation. And then I was just like, I don't know why.
I didn't respond.
It's not okay.
Guys, everybody make fun of me as she gets snap.
Oh no, she gets snapped. She just doesn't snap like us. Yeah.
She snaps. She's doing it wrong. She's like doing this. It makes the same snapping noise. It's just not a regular.
So, this parabola, I hope you guys continued on while I went over there, sorry for that waste of time, is where? Where is this thing?
Right.
This is easy, right? Yeah. We know the 4 down, that's easy. Ethan?
Yeah, so it'd be 4 down and then 3 to the right.
Yeah, Owen and Ethan both say 3 to the right. This is where the whole, what I was talking about with the formula that we use being negative h, we can now say the vertex of this parabola is 3, negative 4. We take the opposite of this value inside the parentheses, and then the actual what's outside your parentheses. So my new vertex, positive 3, negative 4, same intensity parabola. So there, 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 5 points would be real good to get the shape. Because after this, like, if I only do 3 points, I could still really goof up the shape of this. But if I kind of put it through, well, those are stacked on top of each other, so that's not going to work. But if you do it correctly, since this point's supposed to be there, actually. So my sketches up here will never be perfect, but they will have at least 5 points that are correct. Any question?
I already knew this because I already drafted them.
Okay, Jenny.
Yes, but the question is without the calculator, we'd be able to remember it and do this.
Well, we used a mix, kinda.
No, I can do it.
With a calculator.
No, without a calculator.
Are we letting?
I just learned how to do it without a calculator.
Are we letting to calculate?
I'm thinking you know what
We don't need to.
Because,
I'm actually going to switch screens this way.
There, that's you.
So, it wants us to find the x and y intercepts from your vertex. Regardless of where your vertex is, if the parabola has a standard slope, the relationship of distance from vertex and vertical change will stay the same. So the reason I graph this parabola first is to look at, we go over 1, up 1, over 2, up 4, right? Over 3, up 9, that standard behavior of x squared. Over 1, up 1, over 2, up 4, well, there's an x-intercept. There's an x-intercept. And then if I went over 3 to get back to the axis, up 9, my drawing was slightly off, but it should be right there, I believe. So we went 1, 2, 3, which means with the x squared relationship behavior, it's going to have to go up 9. Yep. So my blue drawing was a little goofed up.
So it would be at 0, 5.
Yep. Now the other thing you can do when x is 0, right? Just solve your equation. So the y-intercept, just like always, is when x is 0. So make this 0. Negative 3 squared is 9, minus 4 is 5. And that's just as easy. But with Ava saying, can we use the calculator? I wanted to push that. No, we know a lot of things based off knowing the intensity of the slope did not change. Does this process make sense? Good. I am not on that presentation. C, standard form then. How do we get back to standard form, and what is standard form?
Oh, wait, I think I can do this part.
Who can just tell me what version is standard
Okay,
form?
well,
Colin, thank you.
AX squared plus BX plus C.
Yeah, that one. The AX B C, AX squared BX C, standard forms. So, we just do this, right? We got to FOIL your x minus 3 squared, and then just subtract 4 from what you have. So that gives me x squared minus 6x plus 9. Be careful. I wonder, does this C value here, it's telling me the y-intercept. Is it always going to? In standard form, to re-ask my question a different way, in standard form, is C always going to tell me my y-intercept? It works out here, but sometimes that's just happening and there's no rule.
which is random equation.
Oh, sorry.
No, we don't need to test it. Think it through.
I thought it was no, but
What is the y-intercept? Who can elaborate? Not like for this specific situation, or just what is a y-intercept?
the point where x equals 0, which is what the point on the y-axis was just on the y-axis. 0 as I said on the
Yeah, the point in the function, if we want to speak more vaguely, the point in the function where there is no input value. In a standard form equation,
Yeah, knows.
I want to keep elaborating for just a moment. In a standard form equation of ax squared plus bx plus c, when we make our input disappear or be 0, yeah, then you only have the constant left, which is c, which indicates our y-intercept. So this is the weird thing that you have to kind of do some brain switching as you look at these equations. In the perfect square form, or completing the square form, because this isn't perfect square, but this is perfect square, this does not tell us y-intercept, it tells us part of the vertex. But in standard form, we get our y-intercept. Isn't that kind of cool? I mean, it just makes things easy. So you don't need to, check it in your calculator or have it do it for you.
It's nice.
Yeah, it's nice. Quadratics are odd. Okay, let's move on to the next. Yes. But I need to, have it here. This is why, and please write this in your notes again just to help get it in
We're not done yet.
your brain, long-term memory.
No, we did this part. We're doing E, not D. Well, we're skipping around J.
Are we doing
D or
Yes,
E?
well, so we just essentially talked about D.
Okay.
So with sketching the parabola, we knew from vertex form, the vertex, and we knew the intensity, right, the slope in a way. From standard form, we know the y-intercept. So, graphing form, or what is often kind of called vertex form, which that's how I know it. Nobody back when I learned to call it graphing form. Vertex form is more like formal. This is where, a reminder from yesterday.
Stop.
Oh, no.
You're doing after
Form.
We did a lot of diagrams.
formal.
Okay, this is why, because we want to be able to say a vertex of point and point, right? We're not going to goof with how we present the points. So if your vertex is 3, 2, when plugged into graphing form, it becomes x minus 3 squared plus 2. So you just have to remember it.
And then from there you can easily make it into the regular form.
If you want to be able to think
Squared.
about just plugging in x, you gotta make sure you remember this is a minus.
That's nice.
Coming together.
Finally.
All right. Do 24. You guys, you don't need me.
I wouldn't.
Did we just
No, we didn't. Functions and graphing forms, how do we reverse this process?
so we're trying to get the graphic form?
So, you guys are smart, so you obviously already know that that's what we just found, right?
Yeah, we just found it.
But what it's trying to get you to think about is what is a decent method to get this into vertex form.
Okay.
Oh.
What?
Oh.
Why would you think about it?
Yeah, I get it. You're busy. But just make sure you understand stuff. Or am I mistaken? I could be mistaken. But as I look through there, I feel like there was some that weren't.
This part and we just leave this out.
I don't know.
No, we have to make it look like this. No, because we have to make it look like this. We have to put this in and back.
Well, I thought you could try doing like
I don't think that's how.
perfect square.
I'm gonna try it better.
And then you see that there's 9. So you plus 9, and then you try to make the 9 5 or 4 and making it negative.
If you factor it, then it's the reverse. No, look back at the
Sorry.
x-intercept. If you factor it, then it's negative 5, negative 1, right?
No, but you have to make this one 9 and 5 negative 1, right? So you can make it still.
So you're saying factor.
Get it? It's like what we did
Go
before.
follow
Factor it
step.
first, then you know the x-intercepts. And then use
X minus 4 that's
that's all I know right
I
now.
love what just happened.
Write it down.
I don't know where to go from there, but I know that.
Do you realize that you two are saying two completely different things?
What?
But
I know.
by working together, that's everything.
X squared.
Yeah.
Tell me what you said.
Whoa!
Okay, what I was
But
gonna
this is
say
not in
is
graph.
that you can try making it into like a perfect square.
Well,
because
what do you want me to
you
do?
need the
Here,
perfect square to
make
like
this look
that.
like this. This
Uh,
is right. You have to make it look like that.
You know what I mean, right? Like
Yeah.
x minus h
That's what
squared. So what I did was that you took the equation x squared minus 6x plus
Look.
5,
Take
Look,
that.
look, look, look.
and you try to make it into like
See, look.
a perfect
We don't
square.
have an A in this
So
equation.
for the x
It's x
squared,
squared.
negative 6x. So that'd be x minus 3
Just
squared.
look. Add
So
9.
because
See?
of that,
You see it?
get
Oh, no, 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 wait, hold on.
Why 9?
Wait.
So that you
It's
have
not 9. Okay,
4.
so this equals so negative 4. See? Because look.
Why?
So here's the 2.
That's it. Oh, nothing.
Why? No, why is
Alright, so look, x
Why
squared.
is why is
Yeah.
this?
See, look, look.
Yay.
No, erase the x.
So really, the graphing form
Ruined
is just
everything.
the perfect square with everything on one side.
Ruined it.
Well, it isn't
See, look,
plus
look.
9 minus 4, it's just minus 4.
Yeah.
Yay! I did it!
You didn't run.
So we should try to run everything to make sure that
Then
we actually-
add 4. See? Minus 4. See? Do you see? And this turns into this equation. You see it?
Oh, yeah, I see now.
I don't know why.
That,
Do you
that,
understand it? So it's like you.
Now when it's
Yeah, because you factor, and then it's just find what makes this track.
Okay,
a
so
lot,
especially
right?
if you looked at 25, most conversations I was observing were talking about completing the square. However, then Ava, in a pivotal moment,
Alright.
which I don't care,
what's people?
like an epiphany, when you have like a realization, like
Like,
the cake is a lie! Oh,
what?
For presidential cake, only the bottom of
I'm
it.
sorry, I'm missing something here. But anyway.
Play Portal, it's a great game.
Yeah.
That You'll understand the cake is a
I
lie if you play
understand what it
Portal.
is already.
Portal 1 though, not Portal
Okay.
Don't choose about
But at any rate, if you factor it, then
Oh, they wanted your x squared's top left.
Yeah.
No, you're fucking
Just keep doing
perfect.
it.
That is so good.
Anyway, once you have this, and then you have this.
So remember back when we were using algebra tiles?
I know.
That's what Ava's thinking about.
I still do that sometimes.
good old
It's very easy.
Okay.
So, can you draw the algebra tiles or do you want me to?
Yes.
Alright, and then.
Wow. Remember working with algebra tiles.
Oh,
Remember
I
that
remember.
math is representative of the physical,
we know
of
what you're doing.
actual
Oh, my
things
goodness.
happening.
We know what you're trying to show.
No, that's the why.
You know what I'm doing.
Okay.
Maybe you put one too many X's.
That's the
Actually.
wrong way. What?
Alright, can I
I
please?
don't like algebra
Keep it
tiles.
clean. Keep it
I don't
clean.
know.
She made a
Okay.
pretty looking US flag.
Yay! Okay, but once I factored it, I looked back at the x-intercepts that we figured out earlier. The x-intercepts are 5 and 1,
Yeah.
negative 5 and negative 1.
Ooh, that's
So.
Yeah.
Alright,
They
yes,
always
stop.
are.
I know.
That's how I do it. So wait, what was
These
that?
are all X's.
Let's do like
The, well, negative X's.
intercepts from the graph.
Right
And then-
here
So you can
is your 5. That's how Ava factored it. Okay, so her. You could have stayed up here because I don't need to take this part.
Well, that's what I did.
So she's got this, right? Factored form of the quadratic, not trying to make it fit in a perfect square, because we don't care, it's a rectangle, it works. This,
Oh, well, okay, the x-intercepts are the opposite of the constants.
I knew that.
so your x's, your zeros, are at 1 and 5. Please make sure you have this written down in some shape or fashion. You're just like staring at me. Your eyes just.
I already have this at 5 and 1.
How do I see how you use that, like, for our advantage? I get that you can find intercepts from there.
I think that's the only advantage
Oh,
that I can see.
Your vertex now, right? We know is 3, negative 4.
So then you can do it to find the vertex. You can find 3 of the points, and you just have to find 2 more. And then you can make
Oh, now you don't need to find 2 more. That was when we were just manually graphing by plugging values in. Now that you have this, throw your vertex on there, throw your other 2 points on the zeros, go from your vertex through your zeros, and then just put a couple arrows on it. If you're just sketching the graph, this is everything you need to know. Isn't that cool?
It's wonderful.
You don't have to agree that it's cool. But back in my day, because I wasn't that great at math, I was not as good as you guys are.
You're like 20, in your 20s.
Dude, I was in this class 15 years ago. So let's have that conversation.
Oh.
You're 28. So you guys are like 13, 14, right? That was 15 years ago for me, because I turned 29 next month. Yeah, I am young, but it was a minute ago.
Wait, you said back in my day, and I'm just like, okay, you're not that
15
old.
years, it was like over a decade.
That is almost.
You're a millennial. You're not that old.
Right, you're not a millennial.
Class at
Yeah.
the same time that we were. Because
Well, you're right. It was probably freshman. Well, the problem is we did algebra, geometry, algebra 2.
Yeah,
so
that's
like,
what Jenny does.
it was a different breakup.
Oh, yeah.
And they do algebra. Like, I know my cousin, she does algebra 1 right now, but she's like doing stuff that I didn't know
What do you want?
Yeah, because it's broken up different.
Yeah.
So, here's the point of what I'm getting at. I never understood completing the square, honestly, probably till CPM retaught it to me because I had to learn how to teach it in a different way. I understood factoring very well. Factoring made sense to me. But that only gives you your zeros, and you still don't know the intensity of your parabola because even though you know your zeros, you don't know if it's flipped up or down, and you don't know how tight it's going to end up.
Were we supposed to know that the
Well,
coefficient was 5 and
well,
The vertex,
yes,
then you will know.
but I just mean with just the zeros. Like if somebody gave you just the zeros of the parabola.
Were we supposed to know that we could find the x-intercepts just from factoring? Because I had no idea.
Good afternoon, Madison Roush, please come to the office. Madison Roush, please come to the office. Thank
We
you.
did talk about that because those are the ways that you can make the y equals 0.
Because there was that one question on the Star Wars.
Because
Got it.
this
Alright, I got it.
About where it was like, it was
goes
like
in the
this
galaxy and
graph.
out of the galaxy.
Yeah, and then we were all like, wait, it doesn't fit on the graph card.
So,
I had
this
it
is
now.
really funny. You know how we keep referencing like CPM is like spiral taught? We were here and then we went, and now we're back here but a little wider out and you forgot in this amount of time. And you know what I mean? I'm serious. That's what's happening right now. Okay, we need to go up there. So, in 25, check out these couple quadratic situations and see if you can work with them.
Wait, we did that.
I forgot about that.
So this, sorry, just to clarify, you're not doing this. This is in standard form. This is not in vertex form, but just about there, because if you move the 3 over, we'd be in vertex form. Try both of these in vertex form. We're rewriting these in vertex form. So use the completing the square process.
Oh, okay, well, the first one's
Easy.
yeah.
It's about the same one.
It's almost the same, but I think it's a little easier.
Oh, wait, no. It's also not mine. Not quite.
You guys are
No, it's very weird. It's all of us.
Wait, that doesn't make any sense.
awesome.
How can the vertex be 3? Look, 3 is 0.
So I mean,
Oh, yeah,
Where
it's
you
0.
erase it. But that's not know how to do the quadratic.
Yeah.
Right? Why would you do something you already know instead of learning
Like, would you just be
trying to stand part? Try to fit it into your
oh, I'm just your last choice.
What is?
Where
Where?
not allowed to use how that's and you figure it out.
My dad told me.
Oh, that was your one. Oh my god.
That I stole.
I did that.
I just figured I left it.
I think
I did that on purpose.
It's the only touch it. X-intercept is only negative.
I just think
Yeah,
that should be mean
that's
to
the
you.
vertex too.
Yeah.
You guys are acting back here because I mean, yeah, making sure.
Those are the ones we're supposed to, like, A and B, right? This way we can see over.
Yes.
Yeah,
He is right.
How did I get these things?
How did you
Oh, I-
what's
you
your
already said
Look,
that.
to get one, just put the constant.
This is
will be
my
minus
inbox.
one over here, right?
I
never
got it.
Why
did I never ask?
They said they like to sit back there because they can see over the space.
Yeah, because sometimes people's heads are in the way. But what if they can space out?
Stop.
How does this even work? The whole like try to fit it into completing the square form.
Oh, it works.
How'd you get x plus 3?
Well, 3 plus 3 equals X.
No.
6.
Because
So this is going like that value is always twice the constant in your parentheses, which we now know is actually negative h, right? So if this is negative h,
So the reverse is negative 3. Positive 3.
well, no, this value is 3, but yeah, h is negative 3, right? H is negative 3, quote unquote. So there's always, I don't know, I'm trying to make sure that you guys really understand that you got to flip that. So when we go to vertex, that will be a negative 3.
Get one. Oh,
And this works, right? This one just is what it's supposed to be. So wait, what's that make our vertex?
It makes our vertex the only X-intercept too, so it's negative 3, 0.
Wait, it makes our
Like our
because
vertex
if it's the
only
thing,
it's the same thing as the
square,
X-intercept
so the
because
vertex has to only be 1 point. I don't know what
love.
and that's the only X-intercept.
Alright, I'm struggling on.
I got it.
B,
Wait.
I got the reverse.
I can't really
What do you mean?
I got 0 negative.
So this is always the opposite of the horizontal shift. So it probably didn't go up or down at all. So your vertex can't be
Can I do this one?
up or down. Remember, this is x to
No,
y.
I don't.
Our vertex did not move up or down. Our travel did. It went over.
I think I know.
Yeah.
K value is the X value.
No, yeah, k value's y.
I got it. Stop.
All right. Somebody said they were struggling on.
Can I explain something?
I'd love for you to explain. Do you want to come up here and explain?
she's not gonna explain, she's just gonna write it all down.
And explain it by writing it down. Yeah, that's how that works.
No, explaining means you talk.
Not always.
Oh, look, if you can't understand it, why is it that?
Hey, it's slightly off. I think the calibration.
Pat, Mary.
Okay. So
I know what to do. I don't.
Basically, you want to make this the same as this. So by completing the score, you have to add 9 to that. Okay. So.
Oh.
No. Okay. So much is okay.
Do you want me to write what you taught?
No, it's okay.
Yeah.
Plus
Are you
6.
sure?
Is that
Yes.
okay?
Plus 9 equals
Just recalibrate. Please.
yeah, Jenny.
and then you add.
Oh my goodness.
Okay.
Now how do you write your 8?
Wait, I'm really confused now.
Wait. Okay.
Ah.
So,
Oh, so that you added 8 to both
yes,
sides.
and then you get this is
Oh, Jesus.
X plus.
Is that it?
That's not true.
Is that an 8?
That's not true.
3.
That's
Not a
Oh my
3.
gosh.
That's a
It's a potato.
So it looks like it's marshmallows on a stick, Jenny.
Yeah.
So it would also help you if you turn Probably in, I don't know.
When you
Yes,
take a
Jenny.
picture of this,
There you
don't
go.
let's screenshot this and don't ever delete it.
Okay.
You can be the backdrop for Jenny. So Jenny knows.
Equals this equals this. You want to subtract because this equals x plus x squared plus 6x plus 9, and this equals that, and you want that to equal this. You have to subtract 8 to make it plus 1 instead of plus 9. So you have to.
Does this make sense to us?
Yeah, I got this part. I
can't factor.
Can't factor that.
I'm not saying it's unfactored while you're saying it.
Oh, yeah. There's a reason for that.
Great. Wonderful. Oh, wait, there's the negative page.
Oh.
Wait, it's because you add 8, so it's up. It
You
never does.
subtract.
What you doing there, Jenny?
Because it's x plus 3 times x plus 3 minus 8 if you go to make it into like a bigger
What did
thing.
you?
So you can try using zero product property.
What are you? What is that?
Show this.
Good luck.
It's a person crying.
What are the
There's
two
variables. There's
Oh.
Roman numerals.
Yeah, there's Roman
What?
There's Roman numerals and there's an S and a G.
What's
The person crying.
Oh, I
What are the
saw
first
it.
two
I
things?
saw it.
Good for you.
Wait,
Yeah,
what are the
very
first
nice.
two things?
Alright,
Jenny,
x squared. Right, and they did theirs at the top left, so I'll throw,
What is your calibration work?
because I'm just used to writing slightly off. So then 6x's, right, which if we think about breaking up to make a perfect square, we'd go 3 and 3. So, right, 3x, 3x.
That's
Here, in the perfect square, there is 9. But we don't want 9.
we want 1.
We want 1. So we take the perfect square
I got it.
and subtract 8.
Yeah.
So we take the perfect square and subtract 8. Does it make
Yeah, but how do you negative 3 negative 8 because of
So, we'll get-
math class.
Nobody ever showed this.
Down.
No, nobody ever showed me this. Teaching this didn't exist when we were learning this. So,
Oh,
Evolution. Evolution.
No, Jenny, don't
Evolution.
Evolution. I teach you mathematics.
now,
Cumulative.
this vertex would be left 3, down 8.
Yeah.
Right? But, Ava's asking, how do we factor it? If we didn't care about making a perfect square, is there a way to set it up
Oh, Jenny, chill. I know.
where we can get a perfect
One of them has to be negative.
so we have to use negative x's that would then cancel each other out.
That doesn't work.
I have no idea.
So visually it gets more complicated, right?
I'm not good at visuals. Visuals are my nightmare. Yes.
You're just sitting here so we have an epiphany, right?
So so we're trying to find the zeros, right? That's the point of factoring.
Should we just solve it?
So if we try to think,
Wait, where am I going? I don't know. Should we find out?
we should really move on to the next one.
Well, I want to know
What if we
the
don't know what the
answer.
x
I'll tell you later.
No!
Jenny, no.
This defeats the purpose of solving this.
I take my
Is
toes away.
every quadratic factorable?
No.
Gunnar, look, everyone else is going to say no, but I'll say yeah.
No, I think you can.
No, if you add.
You can't factor it perfectly, but I think you can.
Yeah.
You can just do like an example of negative 8. You take the negative 8 to it.
Yeah, what he said.
So, what you're saying with it not being perfect, then, is it might be really high.
Yes.
But have you guys graphed this? Did you try that?
No. Well, we're gonna do it. We're gonna do it by other versions of math. So it said 0 and something.
It's not a graphing calculator.
Yeah, well, we only have like 3 minutes left. Weird.
No, it's not. It's
Why
bigger.
Whoa.
Sweaty. There's no
There's
graphic
none of
calculator.
this on the homework, though.
Oh.
No,
Ugly.
the numbers. It's not factorable in the algebra style ways that we would love to
Yeah, the
use.
0 is negative 5.82.
So, Gunner's right. Everything's factorable, whether it's a real number or an imaginary number. It's factorable. Now, it might not be worth factoring. Like, so there's gonna bring it back down to earth, Gunner. It might not be worth it. Right? Getting to this point or this point, gross. Quadratic equation, something. Sometimes it's not worth the factor.
So you can factor, it's just not fun.
Right, it's just gross numbers.
So we got the answer.
And then there's our 0.
Wait,
Or,
there is
sorry, our
actually some of
Y-Intercept.
this on the homework. I just cheated.
That's all I know.
Huh?
There is some of this on the homework. I just
Right, so. Let's try to do this right here. Real quick, we got a couple minutes left.
2 minutes.
It's okay if we don't get to 27. Actually.
I need stuff. I want that.
Well,
I
no,
know.
I think that's for now. We need to.
Don't.
Yeah, I do.
God.
Hey, let's focus for just a moment because we got to leave soon.
Connor.
You should teach Mr. Hall how to use smartboard.
No, it's just his smartboard itself is terrible.
No, but like his
Oh,
like he doesn't know how to like make his like pens small. Like they're always like you can't read.
I can read his work, whatever he did last year.
And he writes.
I get kind of OCD about stuff being too. I don't like the
Well,
marker.
you just
on
literally
this.
can't tell if he's writing an X or a K.
I think he just has bad handwriting.
Yeah, I have fun.
He writes his 6's weird and 9's weird. It's really ugly.
Okay.
It bothers me.
Right? Is that? Yeah? Per beat?
It's just like,
What? I'm just dropping these down because we're running out of time.
I think we need to change, like, we need to.
But we need to add something.
Yeah, so then this.
2.25.
Yeah, would have been x squared minus 3x.
So it would be minus 7.25.
Your vertex isn't always going to be in a nice place.
Dang.
What?
I'm sorry, I hate it.
It's just the
I also sound
truth.
very condescending. Sorry about that.
It's all good. It's not my fault.
Ethan Dale and Ellie Koenig to the office, please. Ethan and
Dale.
Ellie.
Everybody say ooh.
Well,
There's a visit, isn't there?
That's tomorrow.
You're gonna prep. Hey, take your stuff.
Oh,
Take your stuff.
Eaton Dale? Eaton Dale.
Wait.
Eating Dale?
Okay,
Wait.
fine.
Wait.
No thanks.
Wait.
Hold.
Uh-oh.
What do we do to deal with this? I can't do perfect square form with 2x squared.
Can't we just divide it all by 2? Just the 29 is not going to be a good
Yeah,
number.
29's ugly.
So if we think about half of this, we'd have x minus, or sorry, plus.
8x plus 14%.
Well, okay, I'm writing the already in perfect square form. So then we'd have x plus 4, right? 14.5. This would normally actually be 16. So difference between 16 and 14.5. Please take your practice seriously tonight. This is really important stuff, especially as you move on and like potentially go engineering or whatever route you guys decide to go. This stuff is important. So please take the practice seriously. I want to take questions tomorrow if we have them. Okay? We're out of time. I'm over time. So sorry for your next class. Awesome job today, guys. I'm super impressed with how quickly you guys picked this up and how bad I was at it when I was a kid.
Why are you impressed that you were bad?
But I'm impressed at you guys based off how bad I was.
Oh.
You guys are easily better at math when I was in 8th grade. I just became a teacher and kept learning how to do it better.
I feel even more inspired story though. Like, I was bad, now I'm good.
You know, now I was like decent at math, but as it got into more complex stuff, it's just I don't think I learned as well.
My dad was good at math.
You
Yeah, my dad was good at math.
Your dad's favorite thing about math is proofs. He's just crazy.
Yeah, I don't know about that.
I don't